Hello, everyone. Hello, Devox. Oh, it seems today half of the talks are about MCP, so yet another talk about MCP. I hope we can learn why it's interesting, why MCP. Okay, some of you didn't know the joke. So we're going to talk about AI agents in Java, including MCP. The menu for today, so for starters, we'll talk about the building blocks for doing AI agents. We'll talk about structured outputs, function calling, and of course, MCP. I suck at this. The main course will be, of course, coding an AI agent using Longchain4j. And for dessert, we'll, of course, do something a bit more fun. We'll have multiple agents working together to do something interesting. You'll see we're going to do a party, and we'll bake an apple pie for our party with agents. So let's get started. We're going to use for this Longchain4j, it's one of the main frameworks for AI in Java with Spring AI. For those who haven't heard about it, like I said, half of the talks about MCP, the other half is about Longchain4j, or sometimes both. So Longchain4j is a version, it's a port to Java of Longchain, which is a popular AI framework in JavaScript and Python. The goal is to help you create AI-based applications in Java, and it's open source, done by a community of many people. There's people from Red Hat, people from Oracle, people from Google, people from Microsoft. By the way, the next session here in the same room, so you don't need to move, it's a panel about Longchain4j with people from Red Hat, Oracle, Google, and Microsoft. So I'll be there also in the next session, so please don't move. By the way, it's fully open source, so you're more than welcome to also contribute. It's fully open. Very happy to have feedback, but also to have contributions to the project. We're going to start with the first starter with structured outputs. For those of, who knows what structured outputs are? Okay, not a lot of people. Okay. Well, you're at the right place anyway, otherwise there wouldn't be any reason to be there. So the first thing to do, we're going to use Longchain4j to connect to LLM. That's the, let's say, most basic configuration. So for that, you need, so on the top left, you see the chat model. That's an interface from Longchain4j that is used to connect to an LLM. And in order to have an implementation, here we're using the OpenAI official chat model, which is an implementation I created, which is using the official OpenAI SDK. So when you connect to an LLM, there's different SDK. I don't know how many there are, maybe 20 or 30. OpenAI has got their own official SDK, which is the one, typically at Microsoft, the one we're pushing, because we work with OpenAI, so of course we want to use the SDK. And to be honest, it's a very good one. I've been using it for several months. It's just a bit weirdly coded because it's in Kotlin. So if you don't know Kotlin, it's a bit weird. Otherwise, it's extremely good. And if you use it here through Longchain4j, you don't really see it. You use Longchain4j APIs, which are an abstraction, and you don't use directly. Unless you do something very weird, you don't use directly the OpenAI official SDK. So in order to use that SDK, you basically need three parameters: the URL to the LLM you're using, the API key to connect to it, and a model. So here I'm using GPT-5 Mini because it's small and fast, and it's by OpenAI, but there's lots of other LLMs, of course, which are available. Then you build this, and then you can use it. So here, I'm going to do an apple pie. Give me the list of ingredients. That's my question. And as you can see, there's a Fluent API that gives me back a text response. Let's do a quick demo of this, just to see how this works. So this is basically the code I've just shown you. I'm going to run this in debug mode, and we're going to see the question going to the LLM and the answer that we have back. So that's the first demo here. And so we can see here the message that went to OpenAI. So there's the content, so my question, I'm doing an apple pie. There's the model name, by the way. And we're getting the answer now. So I'm in the debugger, so we can see here. So it's a string. And the string, well, let me just finish it and see it maybe a bit more graphically here. It's a string that gives you the ingredients for the apple pie. So that's how you connect to it. But that's not very useful if you want to code. Like if you do an agent, you're going to have software components that talk to each other. Strings, well, you can parse them, but that's not super easy. So here comes, of course, structured outputs. So structured outputs, it's a way to force the LLM to answer you following a JSON schema. So if you're a bit old like me, you use the XML schema in the early century. The same thing in JSON. So you can force the LLM to follow a schema, and that schema will be, I want, for my ingredients, I want a title, I want a description of my ingredients. The interesting thing is that because you force the answers, well, you're going to be able to map them to a Java object, which is what we want when we do agents. Two details here. The first thing, you could already ask before to have a JSON answer from the LLM, but you couldn't force the schema. So if you can't force it, you have any kind of JSON, so it's kind of useless. Second thing, you have guarantee of what's coming back to you, but it costs a little bit. If we are lucky, we'll see it's a little bit slower than the previous demo, just because it needs to create the JSON schema. I mean, sorry, it needs to follow the JSON schema. But it's at the cost of quality. So if you want to be able to map your Java object to your answer, well, you need to do this. The way it works by default with OpenAI, I mean, with all LLMs, that supports this. Oh, I forgot to say, not all LLMs support this, and they don't all support it in the same way. So basically, here I'm using the normal OpenAI stuff, and most people are copying from it, so you can expect it will be the same thing everywhere in the very near future. But that's, I would say this is what most people would do today and what everybody will do tomorrow. So you can send you should send the JSON schema to the LLM, so it answers you with the JSON string that follows the schema. And you can write, I mean, you should write it by hand, which is a bit annoying. The way we're doing it here with Long-Chain4j is that we're going to generate that schema for you. So that's a very smart part of Long-Chain4j, where basically we use reflection to look at the Java object that you want. We generate the schema from it. We send the schema to the LLM, and when it's come back, well, we can map the answer with your Java object because it just follows the schema. We're going to have a look at this. It's much better when we look at the code. Just to give you the configuration for this, compared to what I had before, I got like here 3 new methods that I wasn't calling before. The first one is supported capabilities. So here we're telling Long-Chain4j our LLM supports the JSON schema. As they don't all support it, we need to tell it it's supported. And then we need to tell it to follow that schema. So the first method, strict JSON schema, is to tell it I want all my answers to follow that schema. Otherwise, it doesn't need to follow them, so, which is sad. The other strict method, strict tools, it's when you use function calling. So what we'll do just afterwards is to tell also when I use functions, I want to follow the schema also. So when you add those 3 methods, you're guaranteed that you will follow the JSON schema all the time. So let's have a look at the code for this. So I'm going basically to ask for the same question as before. Put it a little bit bigger. So I'm still doing an apple pie. I still want a list of ingredients. But this time I don't want a string as an answer. I want a Java object. So here is a recipe. And the recipe, something I coded myself. It's a record. And the record has got a title and a list of items. And if I look at the items, an item has got a title, a description, and a Boolean field. Just to show, here I've got a Java graph of object, which is a little bit complex. So all I'm doing here, basically, is I'm telling the LLM, I want you to generate a JSON data that follows a schema that could be mapped to this Java object. So Long-Chain4j is going to introspect the Java object, generate the schema, send it to the LLM, and when it will come back, we'll be able to map it. Let me just clear the console. Oh, yeah, I'll clear the console, but we're still in debug mode, so it will probably be easier to follow in debug mode. So here is demo number 2. If we have a look at the console, so the message is a bit more complex than what we just had before. It should be a little bit slower. I didn't took my timer, but yeah, it's a bit slower than before. You see the content of the message is the same. I'm doing an apple pie, blah, blah, blah. But we've got a response format of type JSON schema. Oh, here is the answer. You see it was slower than before. And that JSON schema, if we look at it, it's got a title, it's got items, item is an array, and an item has got some properties, so a title, a description, so exactly what we saw before. So here, Longchain4j was able to introspect my Java object, generate the schema, send the schema to the LLM, and when it came back, as we are debugging, we can see my recipe here. So it's got a title, it's got items. Items, I've got title, description, everything. So I didn't code much, like it's all done by Longchain4j, but basically I want an answer, which is a Java object, and I got it automatically, which is wonderful, and which is the base of what I want to do, of course, agents. Let's just finish this. The end of the demo is basically it's a toString of my recipe object. So it's basically the same answer as before, but now it's structured. It's a structured output. That's going to be very useful in, let's say, 20 minutes, 15 minutes. Second thing we need to discuss before doing agents, function calling or tools calling. Who has been doing this already? Yeah. Yeah, something like not a lot of people. You're all in the right place. Wonderful. So function calling or tools calling, it depends who you talk to. It's the same thing. The goal is to allow an LLM to execute some local code using a JSON payload. I'm talking about JSON. You already understand that it's going to use structured outputs, so what we just did before. So some LLMs, not all of them, have this capability of executing code. Not all of them, of course, but here's like the GPT models from OpenAI can do this. It's fairly recent, but also it's a bit complex, so they don't all do this. Even some recent models don't do it. The model will have a definition of your Java method and of its parameters, and it will decide by itself, well, should it call it, when it call it, and which parameter it should pass to your method. So it's a bit more complex than what we just had before, but we'll see again with Longchain4j. That's very easy to do. This is allowing our LLMs to act, and that gives you two new things that you couldn't do before. The LLM can now gather external information. It can get recent information, like who talked at Devox before me. It can gather private information, what's the travel policy in my company. So it can get information that it couldn't have otherwise. It's a little bit of the same idea as a RAG pattern, but it's not done the same way. You know, the RAG pattern is that you gather your data, you put it in a vector database, and you send it to the LLM. Well, here it's kind of the opposite. It's the LLM getting the data. But in the end, it's the same idea. It's like getting external data, which is recent or private, to your LLM. That's the first thing you can do. So your LLM can now read stuff. And it can also write stuff, so it can execute actions for you. It can book, I don't know, a train ticket, a hotel room for you. That's going to be super useful for agents. So now you can already guess that your agent is able to find the prices of the hotel rooms, and it can book an hotel room for you. So that's going to be extremely useful. I mean, without that, the agents are a bit useless. We're going to have a look at the code, and we're, of course, going to execute it. Yeah, MCP. I hope you did 4 photos. So the way it works, so here I've got 2 chunks of code. The first is a GIST service. I don't know if you all know what a GIST is. In GitHub, it's a small piece of text that you can put on GitHub. I'm using this for this demo because it's a fun way to post some stuff that is publicly available. So I coded a GIST service by myself. So it's a tool that is able to write GIST. We'll have a look at the code just afterwards. What needs to be discussed, I mean, the only important thing is you've got 2 annotations. You've got add tool. So that's a Longchain4j annotation, which says this is a tool that the LLM can use. It's got a description. The description is important. That's how the LLM knows what this tool is doing. And you've got an add p annotation that's a parameter. So here, the LLM will know, OK, I've got this tool, which does that, which takes this parameter, and that tool is available. So maybe I will call it if I need it. So that's how you configure the tool. And then the way you run it, if you look at that code, so I've expanded a little bit my text. It's a bit more complex than before. We're still doing an apple pie, but that now we want to post the list of ingredients to a GitHub GIST. And guess what? If you look at the configuration, it's a little bit more complex than before. I've got one more method. I've got the .tools method that gets the GIST service as a parameter. So now, just with that configuration, the LLM will know, oh, I've got a tool that is available that can do this. And basically, that's what I want to do. So we can guess the LLM will call it. let's have a look at the code for this one. So here it is. So again, compared to what we had before, we just have this on top of it. Well, sorry, and the text is a bit more complex. Now we want to write everything in the GitHub gist. And if I go to the gist service again, so that's by the way, that's a Spring Bean. That's why it's annotated add service. But the Spring Bean, that Spring Bean has got an add tool annotation. So here's what it does. And that p parameter. And then there's the code. So I can code, of course, whatever I want here. It's Java code. Let's execute this. Oh, sorry. Let me clean up the console before, because otherwise it's going to be a mess to see what's going on. So let's execute this function calling. So same message as before, but again, a bit more complicated. So this time you can see we have the same content. So I'm doing an apple pie. We still have the response format, which is of type, scrolling, which is of type JSON schema, and we've got the JSON schema, so what we just saw before in the first starter. But this time we've got something new. Here you can see we've got tools, functions, write gist. So what we're telling the LLM this time is you also got that tool that is available. By the way, you can have many tools. You can have, I don't know, 10, 20 tools. If you got too many of them, you've got two impacts. The first one, it consumes tokens. You send more stuff to the LLM, so it costs money, and maybe some time also. The second thing is that it might confuse it. If you have got too many tools that do the same thing, well, the LLM is, like you've got too many tools, you don't know what to do. Maybe you will use the wrong tool. So don't abuse it, and that's what also we will see with agents. The goal is to give to your agent the correct tools to do the job and not too many of them. Let's have a look at what's happening after that. So we've got an answer for the LLM, which is something similar to what we had before. Like if we have a look here, we've got the ingredients for our apple pie, but it's doing something that we didn't have before. It's saying, OK, I want to call, you see here, call ID, write gist, sorry, where is it? Type function, call ID, here it is. I want to write, to execute that gist function, and it's going to execute it. That's what's happening right here. I'm executing the function, and then it's coming back to me. So I'm going to have an answer from the LLM, but that's not what is important. What is important is in my gist here, if I refresh, I've got a new gist that I just created, you see 1 minute ago, so that's it. And if you go to that gist, you've got indeed the ingredients of the apple pie, which is available. Much easier to share your shopping list when you want to do an apple pie than what we had before. So we've seen structured output, we've seen function calling. Now let's get to the next level, to the famous why MCP. The issue we had with the functions is that they were local, so you need to code them. So I coded with my little fingers the Java code to send data to a GitHub gist. But that's a bit annoying because what you would prefer to have is to be able to use external services done by other people. Typically, GitHub is doing an MCP server, which can, of course, do gist. And it's all coded by GitHub, maintained by them, and you have nothing to do if you could use that. MCP is a standard protocol to do those remote calls. So you can now use not only local code, so what we just did before, but you can use remote servers, which can even also be coded in other languages. It's a JSON over HTTP or I/O. And since that was released a bit less than 1 year ago by Anthropic, this has been hugely successful because basically everybody wants to have their tools available like this so people can use them or misuse them easily. In Java, we're super lucky because we've got the Spring AI team, which is doing the official MCP SDK for Java, which allows you to do MCP servers if you want to do some, which is very easy to do. It's basically a couple of annotations, and your function is now available as over MCP. But I would say most importantly for, normal people, is to use MCP as a client. So here in LangChain4j, we're going to see how we can now execute a remote function over MCP. By the way, MCP, you've got two protocols. You've got I/O, which is on the console, which is basic, but which is what I'm going to use because it's easier. You've got HTTP, so over HTTP, of course, it can be distributed over the internet very easily. The way we're going to use it, it's very similar from a user point of view to function calling, but now it's remote. And of course, structured outputs will work. There's a link between everything I'm doing obviously. Oh, sorry, I forgot. I got some code right here just to show how it's configured inside Longchain4j. So here I'm going to run the GitHub MCP server. I'm going to run it inside Docker in console mode. So that's the most basic way to use it. You could use it over HTTP, so it's being run by somebody else, but then I had nothing to show, so I'm running it here locally. The important thing is at the end, you've got a tool provider, and basically we build an MCP tool provider, and we're going to send it here as a Spring Bean. And then, well, let's just go directly to the code. I'm just going to clear the console again. And so here it is, demo number 4. So this time, instead, number 3 was interesting. No, number 3, I had a .tools, and I was giving my local service. And now I've got a .tool provider, and the tool provider takes as a parameter my MCP server. So it's a client to the server. So basically the same configuration as before, but now I don't do a local call, I do a remote call over MCP. By the way, they can be mixed, so you can have local and remote tools, and you can have several of them. Again, don't abuse it, but you can have many of all of those together. Let's have a look at this. So this time we've got a new question, by the way. I wanted to do something a bit more complicated that I couldn't code by myself. So we ask, who are the authors of the last 20 commits in the Longchain4j repository, ordered by number of commits? So that's a fairly complex question. My LLM cannot answer this, of course. It doesn't know, without calling a tool, it cannot know what are the last 20 commits in Longchain4j. By the way, I don't even know, because maybe something was committed 5 minutes ago, so we might have some surprise. And in order to do that, it's going to obviously use our GitHub MCP server. Let's run this and have a look at the logs. And that's demo number 4. So the first thing it does, I was waiting to scroll because I knew it would be a mess. So the first thing it does, the MCP server is showing its capabilities. That's how Longchain4j will be able to know what it can do. And, well, the cool thing and the annoying thing with that MCP server is that by default, you can filter this, of course, but by default, it gives you a ton of tools. That's why it was scrolling like crazy. You've got all those tools which are available. You can do see the last authors, but you can do gist. You can do, well, lots of things that you can do on GitHub are available here. So I'm still having my question. So I can't find here it is, my cursor. So still having the question, still having a response in JSON schema. Oh, by the way, it's a new object with a list of authors. Not super important. But, and I've got a lot of tools which are available now. Let's just have a look at the answers. So it worked correctly. So here's the last people who have committed on Longchain4j. So you've got Dimitro, who's the lead, of course, and lots of other people I know, some of them. I don't know, so Mario, of course, I know Mario. And I don't know who need guy coding null is. I just saw it before, but first name and last name that you put on GitHub. Again, Longchain4j is open source. Anybody can contribute. Even need guy coding null can contribute. It's fine. So here we were able to call an MCP server and use that data inside Longchain4j, and we were using also structured outputs to have a nice Java object at the end. Now that we've seen this, we're ready to create an agent. We've seen the 3 building blocks, so structured output, function calling, MCP. And so first, let's start with what's an agent, an AI agent. So it's a software component that can act autonomously. So it's triggered by something. It could be an HTTP request, like I'm doing, but it could be a cron job, like every 5 minutes, I have a look at the latest prices for flights to Antwerp. So it's getting triggered by something. It's going to use an LLM to be smart. Otherwise, it's not an AI agent, of course. And it can use tools either to get data, so read stuff, or act on your behalf, write stuff. There's a new module in Longchain4j to do that, which is called agentic. It was coded by Mayo Fusco over the summer, so it's fairly recent, but we're going to see that it's totally usable already. And it's fairly simple to use. So we're first going to code our first agent, which is simple evolution, the first demo when we were doing apple pies. And then we're going to do something more complex, of course. That first agent is going to use an LLM. It's going to use structured output. We're not going to use function calling on MCP yet, because that's the first one. And then for the next agents, it's going to be more complex, of course. Let me show this on the dashboard. So at the moment, we're only doing this first agent. You can see it's going to be filled up in a minute. So the first agent is a recipe agent. It's able to do apple pies for you, find the ingredients. And for that, it uses an LLM. Let's have a look at the code of that agent. Here it is. So if we have a look, if we have a quick look, it looks a lot like what we had before. If I put them here, we were using AI services. Now we're using agentic services. The name is different. Then we've got a builder that takes your interface. It's got a chat model. Oh, and it could, so we're not using tools yet, but of course it could use tools or MCP servers. It looks the same. What's a little bit different is if we have a look at the interface here. That interface now has got 3 annotations. There's the first annotation, which is @agent. So we're saying, so this is an agent, and here is what it does. This text could be useful depending on what you do, but let's say it's usually useful. So it will, if an LLM uses that agent, it knows what that agent can do. What's even more important for me, it's the user message. So this is what we're sending to the LLM. So here we're sending it and doing a recipe called a recipe name. Give me the list of ingredients. So what we did before, but this time we've got a little templating language here. You can see the curly brackets. And what's in parameter is, of course, the addv annotated variable here. So we send a parameter, and it's automatically added with the templating here to what is sent to the LLM. So now the LLM is able to use that agent, send that correct question, and use structured output, of course, to still get some correct recipes in Java. So a little bit similar to what we had before. We're going to see in the next demos why we do it that way, because initially it's why is it a little bit different, but not that much different? What's going on? Let's just execute it to see that basically it's doing the same thing, and then let's see why this is interesting. So I'm going to, let me first close the console, because otherwise it's a big mess. Sorry, debugging, clear all, and one agent. So if we have a look, it's basically going to be the same as before. You can see the content here. I'm doing a recipe called apple pie. You see the templating worked. It's putting the apple pie as a parameter. And then you've got the JSON schema and the answer, and basically the same as before. It's taking some time to execute. Yeah. Let's go on, because it's going to be the same thing. So we just saw a very simple agent. Now, why are we doing it, and why is it interesting? It's when you want to use, of course, multiple agents together. So here we're going to do something more complex. We're going to reuse many of the demos we've done before. So now the idea is that the Longchain4j team just did a release for DevOps. So we want to do a party, and for that we want to do an apple pie. So we're going to need who coded the last commits. We're going to need the ingredients. We're going to create a shopping list, and then we're going to put it in a gist file so we can, of course, know what to buy. So for that, we're going to need some more agents. We're going to need, of course, a recipe agent. We're going to need an agent that finds the GitHub authors. So this one uses an LLM and a GitHub MCP server. Let's have a look at the code of that one, by the way. So the recipe agent, so that's the same copy-pasted stuff as before. The GitHub authors agent is here. So same thing, uses agentic services. It has got here an interface which is annotated with @agent, @user message, and it's got one parameter. And let's go here. But this one, the GitHub author agent, uses a tool, an MCP server, which is available remotely. Those 2 agents are doing something new that we didn't have before. You can see here the output name. So what's going to happen now is that we have a shared memory that is shared across all agents. So we're going to be able to put some context when we start the agents, and we're being able to have some new things appearing in our context. So that's basically a hash map when you've got a key and some values, which can be Java objects if you're using structured outputs. And the agents are going to be able to read from that context and write into that context. So that will allow them to work together. That's the first thing. The second thing that's happening is that they can be orchestrated. So that first orchestration is super simple. Oh, hang on. Let's first have a look at it graphically. So what I want now is the data broker agent. So the data broker agent is not really an agent like the others. This one is just orchestrating the two others. There's two ways to do those workflows in Longchain4j. You can either do what we call pure agentic workflows. So there's an LLM, and we put some text to tell the workflow agent what to do. So I want to get the recipes, I want to get the GitHub authors, and you hope that the LLM will call it correctly. Or there's an API to do this, a Java API, which is what I'm doing here. So if you look at the data broker agent, it's got parallel builder and two sub-agents, the recipe and the GitHub authors. Two interesting things here compared to using an LLM. First of all, I'm forcing it to call them compared to an LLM, so it's forced. Also, it's faster, by the way. You don't have to wait for the LLM to answer you. And the other thing is that you can call them in parallel, something that the LLM will struggle to do. So here, I'm going to run two background threads, one thread which is going to fetch the recipes, one which is going to fetch the GitHub authors. So what's interesting with the agents here is, again, two things, a shared memory and a workflow, which we couldn't do easily before. I mean, you could always code it, of course, but it's done for you. So those three agents are going to work together to bring you back the recipe and the authors. We're going to have a third agent, which is going to create the shopping list for us. That agent uses also an LLM, and this time it's going to use Java function. Let's just have a look at it. Here it is. Same thing as before. Agentic services uses an interface that I've coded. That interface has got an @agent annotation, which tells what it's doing, an @user message, which is what we'll send to the LLM. So you're creating a shopping list for a recipe. We want it in Markdown. For this, you'll need the list of authors and the recipe. And as a parameter, it's taking authors and recipes. So we can hope that the LLM will understand that and will call this correctly. Let's go back to it. Yeah, here it is. So the shopping list agent is going to call the Java function, send the correct parameters, and those parameters, so the author and the recipe are coming from here. So it was the output name here and here. So here you can see the different agents that's sending data in the shared memory or reading data from the memory and then using it to do some new data. That new data will be here. It will be a content, so it will be the shopping list that we want with the ingredients which are assigned to the different authors of Longchain4j. Once we have done all of this, we want one last, let me do it graphically. We want one last agent, the GIST service agent, so that GIST service agent is able to create a GitHub GIST for you. So it's going to post to GitHub our shopping list. Let's just have a look at it. So same as before, that agent, if we click on it, it's got an @agent annotation, @user message annotation with the text, write the following content in a GitHub GIST, and return the URL of the GIST. And as a parameter, it's taking the content which was created by the previous agent. And I need a last orchestrator to orchestrate all this. Again, two ways to orchestrate agents, either using pure agentic AI, so there's an LLM and you tell it what you want, or what I'm doing right here, I'm going to use a Java API for this. I just want to call them sequentially. I'm not going to waste my time with an LLM for this. It's super easy to code. So if we look at the code here, here it is. It's a sequence builder, and it's got my 3 agents as a parameter. And it's going to give me back the URL of my GIST. Now that I have all of this, let's just have a look again at the shared memory. Oh, sorry. That's what we're configuring right here. We can see that in order to execute all of this, I need to give it some context. So the context, again, is a key value pair, which is shared. And we want a repository and recipe name and send this to the agents to have an answer. Let's just have a look graphically. So I'm giving the apple pie and long-chain4j parameters in memory. This is the orchestrated agent, which is sending it first to the data broker agent, which is sending it to the recipe agent and the GitHub authors agent. Coming back, we're having the recipe and the authors. This is called in parallel, so we'll see we've got 2 background threads which are being sent. Once we get them, we process that data. So we're going to have some content back, and then there's a sequential call to send everything to GitHub. So here we see 6 different agents working together, having some shared memory and a workflow, which is pretty complete. And we see that it works fairly well, and the API is quite simple to use. Let's execute this. And first, let me clean up the console again. So I'm going to execute this. It takes some time. So while it executes, let me just detail a little bit. So the question I always have when I show this, why are we doing all of this? Like, it's a little bit like the monoliths and the microservices discussion. Why couldn't I have just one big prompt that tells everything? I want the recipe, I want the GitHub authors. You have a big prompt that tells everything. You give it all the tools, like I'm using 3 tools. You send all the tools to it, and basically it would work. It should probably work most of the time. So why am I having all this trouble of splitting this into small, let's say, microservices-like agents? I'm doing this for many different reasons. The first one is to be more precise. If you've got one big LLM that does everything, well, probably it's a very generic LLM. Here, I could have the best LLM for each tools. For each agent. Maybe here, I don't have the same LLM as here. So here, I'm going to take the best LLM, the cheaper one, the faster one. So I'm going to have more precision. I'm also sure of how the workflow will be called. Otherwise, you're not sure. The LLMs can always decide something else. So here I've got something more precise, probably faster. Again, I'm using maybe the best LLMs. I'm also sending them less data. If I send everything to an LLM, including all the GitHub tools, all the tools and MCP servers, well, that's going to send a lot of tokens to the LLM, so it takes time and money, but also it confuses it. It's like, oh, I've got 3 tools, which one should I use at which time? Here, with this workflow, there's no discussion. Here, each agent has the best LLM and the best tool available each time. So probably this is going to be less costly, faster, and more precise. And the last thing when I'm doing this is that I can reuse pieces of this workflow, like the Git service agent. Maybe I want to use it for something else at another time. So it's a little bit like microservices. The goal here is to have something that is split into more precise chunks that can be also reused. And again, because we're using LLM, it's also to have more direction in what we want. We only send them exactly what we want. And basically, for typically the GitHub MCP server, I tell it exactly what I want. So there's no big discussion in the head of the LLM. And you're sure. You have more chances to have a correct answer. You're never sure with an LLM, of course. Let's have a look at what happened behind the scene. Yeah, lots of code of outputs. So first thing we did, so I don't know if you remember, so at the top, so we're doing first the recipe and the GitHub authors running in parallel. So we're going to have 2 background threads. So here you can see virtual thread 142. So that's the list of GitHub authors. So it's getting it. Oh, sorry, it's a tool first. Yeah, this one is big, like we had before. Second thread is 140, so running in parallel. I'm doing the recipe called apple pie. Give me the list of ingredients. Those 2 threads are working at the same time. The first answer, hang on, this is executing. First answer is the list of authors. Okay, so that all the commits, sorry. It's going to find the authors inside the list of commits. Let's go down because that's big. Whoa, that's super big. The second thing that we should be getting here, it's our apple pie ingredients. So our 2 threads went into parallel in background. We got the list of authors, we got the ingredients. They came back. Now we're sending everything to, where is it? To the shopping list. So you are creating a shopping list. And here is the list of authors. so that it got from one of the agents. And here is the apple pie ingredients that you got from the other agent. So we clearly see that it worked for generating sending everything to get the shopping list. And we're getting back here the shopping list. Let's just go back a little bit. Hang on. Because the last thing that it's going to do, here it is. Yeah, write the following content in the GitHub gist. In the GitHub gist, it gives the shopping list to the GitHub gist. And sending it to GitHub. I mean, let's just have a look at the end result anyway. Go back. I should have a second one. Here it is. Yeah, 3 minutes ago, that's this one. And if we look at this list, we can see we now have ingredients, and they're assigned to some people. So Dmitro should buy the apples. Loic should buy the ground cinnamon, whatever that is in English. And so we can see that they've all been orchestrated correctly, and that in the end, we've got the shopping list with ingredients assigned to different people. So let me just go back here to the code. Again, just to detail a little bit what we've done. We've seen all those agents being orchestrated together, having some shared data in memory, using structured output, so you can have objects, in memory that go from one agent to the other. And in the end, our different agents were able to get data, process data, and write data. So exactly what we wanted to do. The current code in Longchain4j again is super recent. So you've seen those annotations. They're pretty recent and simple. I don't expect them to move too much, but you never know. And again, the project is open source. And also in, let's say, 15 minutes in this room, we'll have a panel discussion with the different people from Longchain4j. So if you have any, ideas on how this should be changed, well, it's time to speak. This is being developed, so right moment to discuss. Sorry, I forgot the last animation with the GIST URL. If you want to have a look at this demo, because the demo, as you saw, is fairly complex, you can go to this GitHub repository. So it's a GitHub repository where you've got like 20 demos. It's all of my demos. I did a specific branch for Devox. So don't go to you can go to the main branch to have everything. But if you want this specific demo, the branch is called like Devox 2025. And you've got this specific demo, which is more compact than all of the demos. As I've still got time, let me just detail one more thing, because if I have time, I'm going to use it. One thing I didn't discuss much earlier, when you use Longchain4j, when you do agents, so we said you need to use the best LLM for the job, but also you need to use a good SDK to connect to it. Here again, we're using the OpenAI official SDK. If you look inside Longchain4j, we support a lot of different SDKs. Some are better than others. Some are specific to some tool providers or to some LLMs. The OpenAI one is the official SDK to connect to OpenAI. So it's probably the best one to connect to OpenAI because it's official, it's maintained. As soon as there's a new feature in OpenAI, well, the next day it's available there. And it's supported by OpenAI and Microsoft also for connecting to Azure OpenAI. Oh. By the way, then if you want to use different LLMs, on Azure, we're not the only one, of course. You've got lots of available LLMs. So here I've been using GPT-5 Mini. You could test this code with other LLMs. So you need to use an LLM that does chat compression, because that's what I'm doing. Like if you use DALL-E 3 that does images, that's not going to work well. Maybe you will have an image of an apple pie. that won't work crazy well. The interesting thing here that you can use the best tool for the job for your different agents, and they don't all work the same. So typically, I've had issues with this demo. Like DeepSeek wasn't doing the workflow the same way. So maybe you need to write it differently, in the user messages. The Ministral, I had some issues with structured outputs. Ministral 3B is a little bit old, so maybe that has changed now. So all of those LMs work a little bit differently. So basically, you need to test and maybe you change the SDK, configure it differently to have the best LLM for the job, which is a real job and a real issue. So first thing, have a look at the LLMs. Second thing, which I like to show, because you've seen here, I've been sending quite a lot of data to Azure, token. I've added quite a lot of token back. And I kept saying, that's costing you money. Yes, it's costing me money. That's how Microsoft makes money. I mean, it costs a lot of money also to run in the data center. And if you go here to the resource page, we should see how much this has cost me. So there's one thing here. Oh, I don't know why it's taking so long, but that gives me the time to show you what is costing me money here. Well, different things cost me money, but one thing that costs me money quite a lot is this. Like you can see here, I'm sending a ton of tokens to my LLM. That's my GitHub MCP server. So again, by default, it shows you all the tools that you can do on GitHub. There's lots of them. And they're all available. So what is Longchain4j doing? Well, it sends to the LLM everything. So it tells it, OK, I've got all those tools available. Which one do you want to use? Well, that's sending a lot of tokens to the LLM, and that costs time and, most importantly, money. So that's costing some stuff. So for the last day, oh, we can see the demo, like what we just did right now. So latency, no, sorry, that's latency. Oh, yeah. When I did my test, I was at the hotel, so latency was good. Here I'm at Devox, and the conference Wi-Fi is not as good, so latency is higher. I'm guessing that's it. And so you can see here the tokens that I'm using. And it's a simple demo. You see I've been using quite a lot of tokens very quickly. But let me refresh to have like the tokens from right now. And basically, that demo cost me, I don't know, less than half a cent. Less than $0.50 usually. But that's quite a lot. So that's why it's super important to choose. Like here, I wasn't super careful. You saw I took GPT-5 Mini and so on. There's a lot of work to do in order to find a good LLM for performance and speed, but also for cost. Because that's, of course, costing you money when you send all that data to MCP servers without being too careful. That's why also you saw I was careful not to send too many tools each time. It's confusing, it's the LLM, but most importantly, it costs me money, and I don't want to pay for no reason. It should be a bit higher than this. Yeah, it's a number of requests 1. It should be something more like this. Like I did 14 requests. That's, yeah. And input, output totals. Yeah, and I sound like, yeah, less than 100,000 tokens, but that's quite a lot. So super important when you do agents to have a look at the LLMs that you're using for performance and cost. And that's also why you do agents. Like you don't send everything like a barbaric person. You know, you send everything to the LLM with a big prompt and all the tools. Like people say, OK, let the LLM manage everything. Well, when you do that, it's costing you a lot of money, less precise, takes more time, so it's not very good. We got 2 minutes left, so just as a conclusion, I gave you the URL. If you want to use Longchain4j, if you want to know more about it, again, we've got the panel in, so now 7 minutes, so don't move. And thank you so much for being here today. And YMCP.